Good afternoon, and welcome to Chapter 9, Part 2. We're going to talk about dependent samples t-tests in this lecture. So let's go ahead and review. So if you remember, since the beginning of class, I've been talking about the two types of statistics. Okay? So what are the two types of statistics? Well, we have descriptive statistics and then inferential statistics. So focusing on this diagram, everything we've done in the past and what I'm going to do right now is going to help you stay connected to the course material. Sure, there's a lot of course material, but then it's all really organized into either descriptive statistics or inferential statistics. So the first part of the class, all the way up to exam 1, focused on descriptive statistics, okay? Univariate and then bivariate being related to correlation. So now we're talking about inferential statistics, and inferential statistics will be what we're going to be talking about for the rest of the class. It's just going to take different forms of data, but it's going to use the same logic. Okay, so inferential statistics. Well, we use inferential statistics to make a statement about a population based on sample data. Okay, so the inferential statistics that we've learned so far, t-test to test the difference between rho and zero, okay? Well, our data was R, or a sample correlation, and our goal was to make a statement about rho, or the population, based on our sample data. So that was t-test to test the difference between rho and zero. Then we talked about one sample t-test. Well, again, we had a sample mean, x bar, and we were trying to make a statement about the population mean, mu, based on x bar. Okay? So as you can see, the data is changing, but we're doing the same thing. The one we talked about last time was independent samples t-test. Well, we had x bar 1 minus x bar 2, right? So the sample mean difference, okay? And we're trying to make a statement about the population mean difference, right? That was independent samples t-test. Today we're going to be talking about dependent samples t-test, which is similar to independent samples t-test in that there's two samples, but you'll see with these data, the distributions are dependent on one another, whereas when we talked about independent samples t-test, the distributions weren't dependent on one another. They were different, right? Because we randomly assigned people to write about mortality, and then we randomly assigned other people to write about taking an important exam. So they were separate people in the distribution. Here, what we have is we have the same person, so subject 1, in both distributions, okay? So yeah, so remember this diagram, okay? It's like Hansel and Gretel dropping breadcrumbs. It's gonna help you keep track of where you've been, okay? And really organize the data. Remember, the purpose of this class is I'm giving you a bunch of different statistical tools that you can use, okay? And this is just an entry-level class. You're learning a lot, but it is just an entry-level class. You'll be able to do stuff Probably more than a lot of people, because it's a pretty in-depth class. But of course, there's advanced undergraduate statistics, there's graduate statistics, and people, you know, get their PhD in this subject. But yeah, it's a great start. So that's that. Let me go ahead and erase it, and then we're going to start talking about dependent sample t-tests. Okay, I'm going to go ahead and read the prompt, okay? A researcher hypothesized that college students would have a tendency to be more liberal at the end of college relative to the beginning, okay? A researcher measured the political orientation of 7 college freshmen using a scale that ranged from liberal to conservative, okay? 1 being extremely liberal and 6 being extremely conservative. 4 years later, just before graduation, the same 7 students reported their political orientation again. So here's what's going on here. So 2008, let's say, is the beginning of college, okay? This researcher collected political orientation data from 7 participants, okay? 1 being extremely liberal, 6 being extremely conservative. So here, this person's more towards the liberal side, this person's more towards the conservative side, more towards the conservative side. It looks like this person is somewhere in the middle. So it looks like 3 and 4 are going to be somewhere in the middle, right? So you have the scale 1, 2, 3, 4, 5, 6. Okay, so it looks like we could call 1 extremely liberal, so this is the liberal side. 2 would be probably moderately liberal. 3 would be slightly liberal. 4 would be slightly conservative. 5 would be moderately conservative. 6 would be extremely conservative. Okay, so basically it looks like 1 through 3 are liberal, 1 being extremely, 2 being moderately, 3 being slightly, and then 4 through 6 are conservative, 4 being slightly, 5 being moderate, 6 being extremely conservative. Okay, so liberal, conservative, 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 liberal, conservative. Okay, so these 7 participants were measured on their political orientation at the start of college. In this case, we're calling it 2008. And then 4 years later, graduation, 2012. And then these are their new political orientation scores. Okay. We're going to start this problem just like we started the independent samples t-test. Okay? There's an independent variable, or IV. Okay? And then there's a dependent variable. So the independent variable is what is changing or what is varying. In this case, it's going to be year in college. Okay? And then LVL1, or group 1, is going to be at the beginning of college, which is 2008. Level 2 is at the end of college, which is 2012. And the dependent variable, or DV, is going to be what? What is everyone being measured on? Political orientation. Now commit this to memory. I'm going to erase it so I can write down the null and alternative hypotheses. I'm going to shortcut it here. In my notes I say mu beginning, but I'm just going to say mu b. Okay, so the null hypothesis is mu b, or mu beginning, minus mu end is equal to 0. So the population mean difference of political orientation, so the political orientation population mean for students at the beginning of college minus their political orientation population mean at the end of college may be 0. Retain it as one of many hypotheses that the data support. So this is saying, the null hypothesis is saying that their political orientation did not change from the start of college to the end. Okay, And the alternative hypothesis is saying mu b, or mu before, minus mu e, or mu n, is not equal to 0. The population mean difference of political orientation is not equal to 0. Okay? So, as you can tell, this is our fourth inferential statistic. You have two choices, right? It's not that bad. Two choices. You're either going to reject the null hypothesis and therefore interpret the alternative hypothesis, or you're going to retain the null hypothesis. Two choices, that's all. So here are your null and alternative hypothesis. Going back to the alternative hypothesis for a second. This is saying that political orientation is significantly different between the start and the end of college, meaning on average there's some change. The null hypothesis is saying that political orientation does not change. Okay, take a look at those. I need to erase them. Step 3, as always, we're selecting our alpha. Our alpha is always 0.05. Step 4. Degrees of freedom, n pairs minus 1. How many pairs? 1 pair, 2, 3, 4, 5, 6, 7. 7 pairs. So then our degrees of freedom are going to be 6. So now we need to find our T critical. T crit, alpha 0.05. 6 degrees of freedom. Okay, now let's go ahead and take a moment to go to our T distribution table on Canvas and figure out what this T critical is. Okay, let's go ahead and identify the T critical. Okay, so go ahead and go to Canvas Files, and under Files you'll see a folder for tables, and go ahead and download the T distribution. Okay. Now, our alpha is 0.05, and we have 6 degrees of freedom. So we're always going to use alpha 0.05 two-tailed test. So this is the row we're going to be using for this class. Okay. So 0.05 and 6 degrees of freedom. It looks like our T critical is 2.447. Okay. So we're back and we found out that the T critical is 2.447. Okay. Now we get to draw our little picture. And I think this is something people have had a question about. Okay, so here's our little rejection region graph, okay, or T critical graph, whatever you want to call it. And we find here that we can have a negative T critical, so go ahead and put your negative T critical in. I'm going to erase the T critical above, it's getting in my way. Okay, so I put in the negative T critical, positive T critical, okay. Okay, so we have our T criticals, one on the left, one on the right. Now, if the T we obtain is past this T critical on the left, then P is greater than 0.05, reject the null hypothesis. If the T we obtain is past this T critical on the right, or greater than that T critical, P is less than 0.05, reject the null hypothesis. In the center, P is greater than 0.05, retain the null hypothesis. So once again, if it's between these two T criticals, P is greater than 0.05, retain the null hypothesis. So when you answer these types of questions on the quizzes, go ahead and draw this out. Okay, that's your best way to deal with this. Okay, so the next thing we have to do is we have to figure out our T obtained. So it's going to be D bar means mean difference. Okay. And then we have our standard error of the mean difference. Okay, and then we can further define that by saying standard error of mean difference is going to be S hat D, or the standard deviation of the difference, divided by the square root of n. Perfect. Here it is. Okay. So what we need to do now is we need to figure out the difference. Okay? So think of it as the change in political orientation. So I'm going to create a new variable. I'm going to call it D. 2 minus 4. There was a change in political orientation by 2 units for participant 1. 5 minus 2. Okay. 3. 6 minus 3. 3. 4 minus 2. 2. 6 minus 3. 3. 3 minus 1. 2. 4 minus 2. 2. Okay, so what is this telling us? So 2. 2 is on the more liberal side, right? 2 is moderately liberal. 2 minus 4. If the person became more liberal, they could only go to 1, right? Because they're already moderately liberal, so to become extremely liberal, they would have to have a 1. So if it was 2 minus 1, it would be a positive number, which means they became more liberal. Let's check participant 2. 5. 5 means participant 2 was moderately conservative. 5 minus 2 is 3. So now that's a positive number. Well, what happened? We went from 5, which is moderately conservative, to 2, which is moderately liberal. So what is that telling us? If a participant has a negative difference score, it means they became more liberal. Sorry. If they have a negative difference score, it means they became more conservative, right? Because participant 1 became more conservative. If they have a positive difference score, it means they became more liberal. Let's try this again. Let's test our hypothesis. Okay? Participant 3 started off as 6, which is extremely conservative, and they went to 3, which is what? Slightly liberal. Okay? So their difference is a positive 3. They became more liberal. Okay? 4 is going to be slightly conservative. They went to 2, which is moderately liberal. Their difference is a 2. They became more liberal. So I believe I proved that. If the difference score is negative, they became more conservative. If it's positive, they became more liberal. Okay. So now go ahead and calculate the average difference score. So let's go ahead and find our D bar. Okay. And it should be 1.86. But let's go ahead and do that together. Let me get my calculator. Negative 2 plus 3 plus 3 plus 2 plus 3 plus 2, oops, I did it wrong, plus 2 plus 2. All right, so negative 2 plus 3 plus 3 plus 2 plus 3 plus 2 plus 2. 1, 2, 3, 4, 5, 6, 7. Okay, you add those all up, you get 13 divided by 7 to get the mean, and you get 1.86. Okay, so our sample mean difference is 1.86. So what does that mean? Okay, remember, if it was negative, it would mean on average in our sample, people are becoming more conservative. Because it's a positive difference score, it means people are becoming more liberal on average in our sample, right? This is a sample mean difference. That's key. And we could calculate the standard deviation for this, but I'm just going to go ahead and give it to you. So S hat difference is going to be 1.77. If you want, in the notes posted under files, it shows you how to calculate the standard deviation for the difference. It's the same as we've been doing, except I believe it's using the raw score method, which is slightly different, but really easy to understand. Okay, so cool. So we have our mean difference and we have our standard deviation of the difference. So let's go ahead and do this. 1.77 divided by the square root of n. What's n in this case? It's going to be the number of pairs, or the number of participants. So it's going to be 7. So again, let's go ahead and try this. Okay. So what I'm doing when I'm calculating it again is I'm checking my notes. So you should always do this, especially on the exams, right? Okay, so the square root of 7 is going to be 2.65 about 1.77 divided by 2.65. You're going to get 0.67. Okay, that's what we have in the notes. So this standard error of the difference is going to be, I'll write it down here, 0.67. Okay, so we got that, so now we got to plug it up here. What's our sample mean difference? 1.86 divided by 0.67. Okay, let's go ahead and check this. 1.86 divided by 0.67 is going to be 2.78. Yeah, and that's what we have in the notes. Okay, so our t is equal to 2.78. Okay, so that's our t obtained or t calculated. Now, okay, let's bring it over to this rejection region. Where do you think it goes? 2.78. 2.78 is greater than 2.447. Therefore, you can plot it over here. So the t obtained is equal to 2.78. Okay? So what is our conclusion? P is less than 0.05. Reject the null hypothesis. There we have it. Okay, hey, good work, good work, good work. I'm going to go ahead and erase all of this now. We are done with it. and we're going to do our interpretation. And what you're going to see, this interpretation is going to be pretty much the same as t-test to test the difference between row and zero, one sample t-test, and independent samples t-test. It's all inferential statistics, therefore it's using the same logic. The only thing that's changing is the type of data we're dealing with. Remember, everything's always going to be absolute values. We're always just going to deal with positive numbers. It's a lot easier. Okay, so the t obtained 2.78 is greater than the t critical. Alpha 0.05, 6 degrees of freedom is equal to 2.447. P is less than 0.05. Okay, so just like we saw in the rejection region graph. Therefore, we're going to reject the null hypothesis. Because we reject the null hypothesis, we're going to interpret the alternative hypothesis. It's saying the population mean difference of political orientation is not equal to 0. Because there's a significant difference, we need to go back to the sample data in order to figure out where the difference is. Well, what's our sample data? Okay, it's that mean difference score, right, that we calculated. Okay. Specifically, students tend to be significantly more liberal after college than before college. Remember, we know this because the difference score is positive. If the difference score was negative, it would mean that they become significantly more conservative after college. Okay, the probability of the actual data obtained, and the sample data that we're dealing with in this case is going to be the sample mean difference, 1.86, okay? If the null hypothesis is true, is less than 5%. So once again, we could draw our little picture. So if the null hypothesis is true, so the population mean political orientation at the beginning of college minus the population mean political orientation at the end of college doesn't change, so it's 0. Okay, so that's our population. And we don't get 0, because 0 would be no change. We get a sample mean difference of 1.86. So the probability of us getting our sample mean difference of 1.86, if there's no difference in the population, is going to be greater than 5%. Not greater than 5%, less than 5%, right? P is less than 0.05. Okay, so there's our little picture there. Because of this small probability, it is concluded that the mean difference of the population from which the sample was drawn is not the mean difference specified by the null hypothesis. Because getting the sample mean is a really rare event, we're arguing over here. So once again, I'm going to draw a picture. Mu b minus mu e equals 0. We're arguing over here. Okay, let me add the difference. We're saying that that's not the population that we're dealing with. Okay, that's not the correct population value. It's different than 0. In this case, it's going to be greater than 0, right? Because that's the direction of our sample mean difference. So let's say maybe it's mu b minus mu e equals 1. And that's our population value. This last statement is saying the sample mean difference did not occur by chance in a population where mu1 minus mu2 equals 0. Okay, well let's draw that out. Mu1 minus that should actually say, more correctly to follow what we're doing, it should say mu b minus mu e. So if you're wondering, there's a little correction. So mu b, so once again, here's our hypothetical population, which is the null hypothesis. Okay, sample mean difference did not occur by chance. Remember, what does that mean? What occurs by chance? Values that are close to the population value, or values that are close to the null hypothesis due to sampling error. And the chance of getting those values is going to be greater than 5%. So here's sampling error, right? They're going to be values that are landing close to this null hypothesis. So mean differences that are going to be close to a mean difference of 1. Who knows? Maybe 0.1, negative 0.1, right? But they're all around there, and their chance fluctuations, they're due to sampling error. Okay, but the difference that we found in the sample is so different that we're saying it's not due to sampling error. It's not a chance fluctuation in a population where the null hypothesis is true. So there you have it. And this is the same logic for all of the inferential statistics, right? Same logic. The only thing that's changing is the sample data. So go ahead and take a look at this. You know, if you're starting to understand this, it's awesome, because there's a lot of people, even people who use statistics, that do not understand inferential statistics. Okay? They just do their little SPSS thing, and P is less than 0.05, so they say there's a significant difference, or P is greater than 0.05, so they say there's not a significant difference. They don't understand why, and I'm teaching you why. we rejected the null hypothesis here. What would happen if we retain the null hypothesis? Okay, so let's say we had a value that was 1, plus 1. Okay, so that would be less than our t-critical value, and therefore our p would be greater than 0.05. So that would be, that t obtained of 1 would be between our negative 2.447 and our 2.447. So p is greater than 0.05, retain the null hypothesis. So we would retain the null hypothesis. So we would interpret the null hypothesis. The population mean difference of political orientation may be equal to 0, retain as one of many hypotheses that these data support. Specifically, students tend to be significantly more liberal after college than before college. Specifically, so the null hypothesis is true, meaning nothing happened. So specifically, students, right, do not tend to be significantly more liberal after college than before college. Okay. Yeah, don't really need that there. Okay, so the probability, let me get another red pen. Let's see if that works a little better. Okay, so the probability of the actual data obtained, so getting the sample mean difference that we got. So obviously, this would change as well. If we retain the null hypothesis, this sample mean difference might be something like a 0.6. You see what I mean? Okay. If the null hypothesis is true, it would be greater than 0.05. Because of this large probability, p is greater than 0.05, it is concluded that the mean difference of the population from which the sample was drawn may be the mean difference specified by the null hypothesis. The sample mean difference occurred, so it would be the sample mean difference occurred by chance in a population where the null hypothesis is true. Okay, so our sample mean difference being different from 0 would be a chance fluctuation. Okay. Let's go a little further. I'll take you a little further. Let's draw our pictures again. The probability of the actual data obtained, okay, let's say we had a sample mean difference of 0.6. If the null hypothesis is true, okay, it is greater than 0.05. So let's say the null hypothesis is true, the population mean political orientation before minus the population mean minus the population mean, political orientation mean at the end of college is equal to 0. So the null hypothesis is saying there's no difference, there's no change. Okay. And we had our sample mean difference of 0.6. So the probability of getting our sample mean difference, let's say it was 0.6, if the null hypothesis is true, is greater than 5%. Okay? Now let's do this one. because of this large probability, p is greater than 0.05, it is concluded that the mean difference of the population from which the sample was drawn may be the mean difference specified by the null hypothesis. So once again, we have mu b minus mu e equals 0. Okay? So if our mean difference is 0.6, we're saying here that this may be the true population value. That's all we're saying there. The sample mean difference occurred by chance in a population where the null hypothesis is true. Okay? So remember, sampling error, we talked about this already. So if the null hypothesis is true and you sample from that population, you would expect values that are close to the population value of 0. Okay? The probability of getting those values would be greater than 5%. So all it's saying when we retain the null hypothesis is our sample mean difference of 0.6 in this hypothetical situation is due to sampling error. It's a chance fluctuation. Okay. So there you have it. If we retain the null hypothesis, here's how our interpretation would change. All right, good work. 2 more things to cover. And it's probably not a big surprise. Confidence interval, effect size. Let's do it. So the first thing we're going to talk about is confidence interval. So you already have all of this information. The only difference between the lower limit and the upper limit is lower limit, you're subtracting the right side of the equation. The upper limit, you're adding. Okay, our sample mean difference is 1.86 minus our t-critical, 2.447, multiplied by 0.67, which is our standard error of the sample mean difference. Same exact thing for the upper limit, except we are adding. Okay, adding, subtracting. Let's do this together. Okay, 2.447 multiplied by 0.67. This is going to be 1.64, right? It's the same. Okay. 1.86 minus 1.64, the lower limit is going to be 0.22. $1.86 plus 1.64, 3.5. Okay, let's check the notes. Looks good. Looks good. Okay, so we're 95% confident that the difference in political, it should say political orientation, right? Orientation scores collected before and after college is between 0.22 to 3.5. Positive numbers are indicating more liberal. Okay, so 0.22. Okay, perfect. What do you notice? What's not in there? 0. If 0 was a possibility, you would what? You would retain the null hypothesis, because that's what the null hypothesis is saying. It's saying the population mean difference may be 0. Well, this is telling us, based on our sample data, 0 is not a possibility. Okay, good. Okay, so this is the effect size D. So how big is the difference? Okay, our sample mean difference is 1.86. The standard deviation is 1.77. So we find our D to be 1.05. Remember, plus or minus 0.2 is a small difference. Plus or minus 0.5 is a medium difference. Plus or minus 0.8 is a large difference. Okay, there's a very large, right? Because it's bigger than large, which was 0.8. There's a very large difference between political orientation sample mean scores collected at the beginning of college and those collected at the end of college. So yeah, there was a large difference there. Okay, and that's all I have for you. Let's go ahead and pray. Dear Heavenly Father, thank you so much for this day, Lord. Thank you for giving us the strength to do everything that we have to do in life and really, really to excel. Lord, give us a wisdom to always turn to you, Lord, every day, to just be amazed by this beautiful creation that you've given us, Lord. Every little thing is amazing. The fact that we could even have this online class and all this technology, whiteboards. It's so amazing. Thank you, Lord. And give us a wisdom to turn to you and ask you every single day, Lord, here I am. What do you want me to do? I am here taking the statistics course. I am here, in the major that I am, Lord, what do you want me to do to serve your kingdom? Thank you, Father. Thank you so much for everything. In Jesus' name we pray, amen. Well, thank you very much. Go ahead and email me if you have any questions. Have a great evening.